used for calculating compound interest looks like this. A equals P, and that's a 1, plus R over N raised to the NT power. Lots of variables. Okay? So the A in that formula we call the accumulated balance. Okay? The accumulated balance is the initial amount of the loan, the lending of money. That's the principal. We'll get to that in a second. Plus however much interest has been accrued on that. Okay, so I'm going to say roughly that's P plus I. Principal plus interest. Okay, the P in our formula is the principal. Okay, and roughly speaking, we're going to say that the principal is that initial amount of the loan. Okay? Anytime there's been a lending of money, there's usually interest involved. Okay? And not just credit cards and mortgages and things like that, but you may have a savings account that accrues interest, and you get a little interest on that. Well, the reason you're getting interest on it is you're lending the bank your money, and the bank is taking your money and trying to make more money with it, and in return it's giving you a little bit of the interest back that it earns. It's like minuscule interest. It's pitiful. Really, truly pitiful. Okay. The R in this case is our annual interest rate. Okay. And sometimes we have a tough time distinguishing the interest rate from the interest. Okay, the interest is a dollar amount. Okay, the interest rate is like a percent. Okay, so it's usually given as a percent, but when we use it in the formula, we don't want to use the percent form. We want to use it as a decimal. Okay, the last two variables. Let's do T first. What does T usually stand for? Have y'all figured that out? Time, yeah. But this is going to be picky. Okay? Since this is an annual interest rate, this is the percent per year, our time has to be given in years. Okay? And I'm not going to be tricky with that. Anytime I'll give you a problem that you need to use this formula, then I'll give you the time in years. But on occasion, if you're doing something else, it's like 18 months, then you need to change that 18 months into a year and a half or something like that. Okay? Lastly, N. We're going to say N is the number of times interest is compounding per year. And this is the idea. This is kind of how it goes. Simple interest just says, I'm charging you this percent of the principal for this much time. Okay? And at the end of that time, you do the principal times the interest times the time, and that's, did I say interest? Principal times rate times time. There you go. And that gets you the interest. Well, compound interest goes like this. You have a principal, and we're going to charge you interest on that for a little while. Okay? And at some point, we're going to stop and we're going to say, okay, we're going to take whatever your principal is plus the interest that's accrued. We're going to lump those together so it's not like a bigger number, and we're going to start charging you interest on that bigger number. And we're going to do that for a little while, and then we're going to say, okay, let's see where we are. Let's add this new interest to that old stuff, make a bigger principal. That's compounding interest. Okay? And so N is going to be number, N for number, of times interest is compounded per year. In 1 year. And we're going to practice this. And the most common kind of compounding is monthly. Okay? So if I have something that the interest is being compounded on monthly, even if I'm doing this for 3 years, how many times per year is that? Yeah, how many months are in a year? Yeah, that wasn't a tricky one. Can you name them all? No, I'm not going to do that. Okay? Yeah, there's 12 months in a year. So even if I'm doing this for 3 years or 10 years or 30 years, my n that I'm going to use is 12 for the 12 months. Okay? The 3 years or the 30 years, that's going to get factored in right there when we multiply it times t. Okay? All right. So, question. How much is a savings account worth if it was opened with, sorry about the squeaky chalk. I don't know if it's annoying anyone else. But if it was open with $2,000 at an annual interest rate of, we're going to be generous, we're going to say 4%. Compounded monthly 3 years ago. How much is a savings account going to be worth if it was open with $2,000 at an annual interest rate of 4%, compounded monthly, 3 years ago? And we're assuming that once we opened it with this $2,000, we're not adding anything else to it over time. It's just we opened it and we left it alone. Okay? So in cases like this where you have a formula that has lots of variables, I found it to be a really good idea to just label everything first before I plug things in. Okay? So the first variable, A. Do I know what A is?
No.
And then what the question's asking for. How much is this guy worth after 3 years? What's the accumulated balance? So that's a mystery. Okay? But what about P? Do we know the principal? Yeah, that's the $2,000.
Because when you say principal, you say amount of loan.
Because you're lending the bank your money when you open up a savings account.
So you're looking at it, okay.
It's the starting amount, though. Okay? Now, any of you guys going on to like finite or any other sort of like math of finance, what you're going to find out later, I don't want to ruin anything for you, the principal actually changes over time when you start paying off things or if you start adding on. But we're going to keep it simple because then the formulas become a lot more complicated, like as if this wasn't complicated enough, right? Okay, so we're just going to, in this class, say, once we decide what the principal is, we're going to leave that alone. Okay?